In this video we're going to create an incredibly bright water-cooled LED light that not only looks really awesome but is also extremely versatile. Its versatility is thanks to the use of liquid cooling to take the heat away from the LED, as it allows the light to be angled into a variety of different positions. Another great feature of this light is that we'll be using an LED that looks literally identical to sunlight. Seriously, this thing is amazing. There have been several times where I've used it on a cloudy day and have been later subconsciously convinced that the sun's come out and is streaming through the window. Seriously, it's crazy. This also makes it suitable for video and photography work, as colours are absolutely spot on. It even allowed me to get this really awesome time lapse, as the daisies too were convinced that it was actually sunlight. Although this build is a little bit more on the expensive side compared to what I usually do, it's quickly risen to one of my favourite and most used DIY perks projects, as it provides something very unique and is a genuinely useful tool to have. The build process too is particularly interesting, especially when we get to making the custom brackets for the head. But before we begin, I just want to give a quick shout out to VideoBlocks, who are kindly sponsoring this video. If you've not heard of them before, they are a stock video footage company that offers not only stock footage, but After Effects templates, background plates, and more. They're perfect for YouTubers, as an entire year's access to their whole library is just $99, which is really affordable. And on top of that, they're currently offering a 1-week free trial with which you can download up to 140 clips, which is a great way to explore what they offer, and you get to keep them afterwards, which is fantastic. So if that sounds good to you, feel free to sign up at videoblocks.com/YouTube or by following the link in the description. Right, so let's get on with building this light. The first thing we'll need is obviously the liquid cooler itself. These are usually used for cooling high-end computer processors, and you can find a link to the one I used in the description. We'll be mounting it to a custom frame, for which we'll need a 1 meter length of angled aluminium. The back of the cooler can then be placed at the middle of this length, and then a knife used to mark the position of its outer edges. We can then make some 90-degree V marks at these points like so, and then use a hacksaw to carefully cut them out. Once they're both cut, it's just a case of bending them both into 90-degree angles, after which the frame should match the width of the radiator. To make the legs, the same can be done again, with one V at the end of the radiator, and the other about 6 centimeters further along. These can again be bent into 90-degree angles, after which it should look something like this. As you can see, on the feet I've cut one side of the angle off entirely. This basically means that when the light is completed, the feet can be slid underneath objects on a shelf, meaning you can get it at a high lighting angle without resorting to a mount of some kind. It does make the legs less rigid though, which means that the light is a bit less stable. So if you don't want to mount the light underneath a shelf, I do recommend that you leave this step out. In any case, before we attach the cooler to it, we need to sort out the LED power circuitry. As the LED we'll be using requires about 30 volts, we need to use a voltage booster. This basically takes a lower voltage and steps it up depending on the value of the indicated variable resistor, which you can adjust yourself. This not only allows us to use a variety of power sources to power the light, but it also means that we can add a knob that allows us to easily adjust the brightness of the LED. This board also has the ability to limit current, which is essential if you want to get the most out of these high power LEDs while protecting their longevity. Now, as these boards are a little hard to find, I have, as usual, placed international purchasing links in the description. So the first thing we'll need to add is the aforementioned brightness knob. We'll start by scraping off the glue around the base of the innermost variable resistor, and then bend it back and forth until it breaks free. Some of you may want to desolder it instead, but as we won't be needing it again, it's much easier just to take advantage of metal fatigue. After removing as much of the remaining glue as possible, we can solder 2 extension wires to the outermost of the 3 solder pads. Now we need 2 new variable resistors and also a linear potentiometer, all with a value of 2 kiloohms. These need to be then soldered to the extension wires as shown in this circuit diagram. We'll be using the 2 blue variable resistors to adjust the minimum and maximum brightness points later on in the build, but for now we'll get started on making the platform that the voltage booster will be mounted to. So we'll get some short lengths of aluminium angle and round off their corners with a file so that they fit snugly inside the front of our frame. As these will later be screwed together, we need to drill some holes through them both. Thanks to the 3 points of contact, they'll make the frame much more rigid. So we'll just unscrew them again for now, as it's time to work on the platform itself. To make it, we'll first need to cut a rectangle out of some thin aluminium sheeting, after which we can drill some holes through our short supports into it so that we can again screw them together later. Next we can place our voltage booster on the rectangle and use a sharp point to mark out its mounting hole positions. We'll also need to mark the point directly underneath the variable resistor, so that we can adjust the output current later. Once these are drilled through, we can make two more larger holes adjacent to them, one for the potentiometer to fit through, and the other for a power switch. After the supports have been screwed on with some screws and nuts, it should look something like this, and the last thing to do is get some 15mm long PCB standoffs and securely mount them to the back like so. These standoffs will allow us to later attach the voltage booster with the component side facing inwards, which will not only protect it, but also expose the bottom side of the voltage booster to the airflow from the radiator's fan, which will keep it nice and cool. Now we can screw our platform to the frame, after which it should look something like this. Now, as we'll later be using a microphone gooseneck to support the LED, we'll need to make a mount with which we can later fix it to the frame with. These goosenecks use a fairly uncommon thread, so what we'll need first is an adapter that converts it into a standard 1/4 inch UNC thread instead. Now we can get a small piece of aluminium angle and drill a hole in one side, gradually making it larger until the adapter can be pushed through. This can then be mounted to the back of the frame using screws and nuts. Now it's time to make the holes through which we'll attach the radiator. Now, as the radiator has 4 fan holes on its top and bottom, we'll use the included fan as a template to mark where these holes should be on the frame. Whilst we've got the drill out, we might as well drill 2 pairs of holes on the side and back. These will later be used with cable ties to hold some wires in place. Now we can add our electronics, starting with the power switch. A short length of wire needs to be soldered to one of its tabs, after which it can be inserted through the hole we made earlier. Now we can add the power input connector, which is just a short length of wire with an XT60 socket soldered to one end. This needs to be soldered to the power input of the voltage booster, with the positive wire going through the switch. As you can see, I've also soldered 2 extra black wires to the input, which will later be used to power the pump and fan. Now we need to get some more wire, I'm using an old mains cable here by the way, and solder one end of it to the power output of the voltage booster. We can now screw the voltage booster to the standoffs we added earlier, and after trimming off the unused legs on the variable resistors, we can mount our potentiometer as well, finishing it off by adding a knob. Now we can use some cable ties through those holes we made earlier to hold the wires in place, after which we can finally attach the radiator using its included screws. Now things are going to get pretty interesting as we're reaching the final stages. As I mentioned earlier, we're using a microphone gooseneck to support the LED. It's perfect as it can be bent into different positions and stay there, but it's also hollow, which means we can keep things neat by routing our wires down inside it. The problem is that when we add our thread adapter, one end gets blocked up, so what we'll need to do is drill 3 holes in the side of the base for the wires to enter through instead. We'll start with the LED's power wires, which are hooked up to the output of the voltage booster. Now a piece of stiff steel cable can be pushed through from the other side of the gooseneck and clamped down onto the wire. The whole thing can then be pulled back through the neck, taking the wire with it. Now you may have noticed the little green wire. It has 2 cores inside and is there to later carry power to the pump, which resides in the cooling pad. Now that's done, we can attach the gooseneck to the frame using the thread adapter and a 1/4 inch UNC nut. Now it's time to start my favourite part of this build, which is to make the head. It's essentially a custom bracket for the cooling pad and actually makes the head look quite cool. To make it, we'll start by printing off the template I've included in the description. It needs to be printed without any scaling, and you can use the included measuring box to make sure it's printed at the right size. These templates need to then be stuck to some 6mm thick MDF using double-sided tape. You don't have to use MDF, but it is the most practical option for most people as it's easy to cut through yet sturdy enough for this application. Notice that there are coloured dots on each shape. These mark the hole points that need to be drilled through, and you can see the required bit size by referring to the included key. A coping saw can then be used to carefully cut out the shapes, and after giving them a good sanding down, you should end up with something like this. Notice that the smaller bracket has a countersunk hole in the middle. This is because we'll be using another thread adapter on the gooseneck to attach the brackets to it later. Having it countersunk allows its thread to be exposed, as it's not quite tall enough to just reach through the MDF on its own. The easiest way to make this countersink is by using a spade bit. Now that both brackets have been cut, it's time to prepare them for spraying by giving them at least 5 thin layers of undercoat. This undercoat can then be sanded down using some fine grit sandpaper until it's almost plastic-like in appearance. They can now be sprayed with whatever colour you like. I went with a black satin finish as it gives the appearance of some kind of painted metal, and looks pretty good, I'd say. So now we need 4 20mm long threaded rod connectors, 4 12mm long flanged head screws, and 4 washers, all of which need to be M5. So after inserting our gooseneck adapter into the smaller bracket, we can thread our screws through from the other side, add a washer, and then screw on the rod connectors. Next we need to push our wires through the hole, and screw the bracket tightly to the gooseneck. This gives us a fantastic mount to which we can attach the rest of the head. The next thing we can do is wire up the pump that's in the cooling pad. The connector it uses is a standard computer fan connector, where the middle wire is positive and the wire marked with a 1 is negative. This connector needs to be chopped off and the wires then soldered to the green dual core wire I mentioned earlier. Any excess can be pulled down inside the gooseneck to keep things neat. Now, the liquid cooler comes with mounting hardware for both AMD and Intel processors. As our DIY brackets have been designed for the AMD hardware, we'll get the AMD brackets and insert the included plastic retainers into its holes like so. Now what we need to do is get 4 more flange head M5 screws, this time 25mm long, and push them through the large holes on our other MDF bracket, which can then be inserted through the AMD bracket. To pull the plastic tabs into the holes on the MDF, we can squeeze them together using a wing nut. It's quite a tight fit, but it does do the trick. The whole thing can then be locked onto the notches on the cooling pad and then tightly screwed to the rod connectors using an Allen key. It should now look something like this, and it's finally time to add the LED. Pretty much any similar style 100 watt LED emitter can be used here, but for best results I highly recommend the ones made by Yuji LED, as they have absolutely fantastic colour rendition. They are more expensive than the cheap ones you can get from places like eBay, but as I found out in a previous video, they are well worth the extra, and I can't recommend them enough. To mount the LED, it's just a case of pushing it down onto the pre-applied paste on the cooling pad, and then soldering the power wires to it. Make sure that you get the polarity correct though, as it won't light up otherwise. Now we need a lens to focus the light forwards. As you can see, this thing is huge, and as it's designed specifically for these LEDs, it comes with a suitable reflector and mounting bracket. You can find a link to it in the description. The reflector has 4 little prongs on the bottom, which can be inserted into the matching holes already present on the LED. Once that's done, we can place the lens on top, following it up with the bracket. Now we need 4 25mm long M4 screws with accompanying dome nuts and washers, which can be used to clamp the lens and its reflector in place. Now we can add the fan. As I mentioned earlier, this came with the liquid cooler, and it's just a case of using the included screws to attach it to the radiator. I am however using an extra fan grill, as it will protect the blades if something were to touch them. Looking good. So now the last thing to do is sort out the power source for both the fan and pump. What we'll use for this is a little voltage regulator. This works similarly to the voltage booster we're using to power the LED, only this one is much less powerful and actually reduces the voltage rather than boosting it. So after setting it to output 12 volts, we can solder the input pads to those additional wires we added to the bigger voltage booster earlier. To its output pads we can then solder the pump and fan. The pinout for the fan, by the way, can be found in the video's description. We can now glue it to the frame with a piece of cork in between to act as an insulator, and with that, the light is pretty much complete. But before we power it on, we need to calibrate our power circuitry so that the LED is driven with the perfect amount of current. To do this is really simple, and we'll start by cutting through the positive wire that goes to the LED. I know we literally just put this thing together and we're already cutting it up, but this is the only way to check the LED's current properly, as it does need to be cooled at the same time. We can then hook these wires up to a multimeter so that the current flows through the multimeter rather than directly going to the LED. Now we can insert a little screwdriver into that hole we made earlier on our voltage booster platform and use it to twist the remaining variable resistor on the voltage booster fully clockwise. You should hear a little click click on every full turn once it's at its maximum. We can then do the same to both of our extra variable resistors that we added earlier, but this time they need to be adjusted fully anti-clockwise. We're now ready to power on the LED for the first time, but before we do that we obviously need a power source. The light accepts a DC current rated at anything between 12 and 24 volts, which allows you to use anything from an old laptop adapter to a car battery. The only requirement is that it needs to comfortably provide at least 110 watts. I'm going to use an old printer power brick that outputs 8 amps at 15 volts, meaning that it can supply 120 watts, which is perfect for the LED. As it had a proprietary connector on the output side, I chopped it off and replaced it with an XT60 connector instead. So after plugging it into the light and turning on the power switch, the fan and pump will fire up, as will the LED. You should hear a sort of bubbly noise at first as well from the pump. This is normal and it's a good indicator of it all working properly, and will quieten down after a minute or so. Now the multimeter's display should be telling you that the LED is drawing about 1 amp, and at the moment turning the brightness knob shouldn't really do anything. So we'll make sure that the brightness knob is at its maximum, and then slowly turn the variable resistor on the voltage booster anti-clockwise. You should start to see the LED increase in brightness, and the multimeter should show an increase in current as you go. You need to keep going until the multimeter registers 3 amps, as this is the maximum that the LED is rated for. Now with the maximum current limited to 3 amps, we can adjust the output voltage range so that the LED dims properly when our brightness knob is adjusted. With the brightness knob still set at its maximum point, we'll grab the variable resistor that's wired up in series with the potentiometer and adjust it clockwise until the current starts to dip. We'll then backtrack slightly until it starts to level off. We want to get it as close to this leveling off point as possible, so it may be necessary to backtrack back and forth until we get it right. Now we can turn the brightness knob to its minimum value and then grab the other variable resistor, the one that's connected to the potentiometer in parallel, and then begin turning it clockwise. The multimeter should show the current dropping as you do this, and the LED will decrease in brightness accordingly. This variable resistor basically sets the minimum brightness level of the LED, so you can adjust it to your personal preference. I adjusted mine until it was just slightly glowing. Once you're happy, the variable resistors can be tucked away underneath the radiator. The knob should now smoothly adjust the brightness from minimum to maximum, with the current itself capping out at no more than 3 amps. Now all we've got to do is reattach our cut wire, making it look neat by using some heat shrink. See, that cut wasn't so bad after all, was it? And with that, the light is complete and looking awesome. Now before we wrap this up, it's worth noting that it's also pretty easy to make a wall mount for it. This can be made by chopping off the outer edges on a piece of angled aluminium, which can then be screwed to a wall. The light's legs can then be hooked under it, allowing it to quickly become a pretty interesting looking lighting fixture. Right, so I hope you've enjoyed this video. It was really hard to make because of its length. It took quite a long time, but I'm really happy with the project, as I mean, I built it in December and I've used it in every video I've made since then, so it's been actually a genuinely useful production tool. I didn't really cover the brightness of this in the video, but it is ridiculously bright. It is brighter than the 100 watt flashlight I made a while ago, which was equivalent to about 1000 watts if it was an incandescent light bulb, and that's because the LED is more efficient, because it's a Yuji LED and they're much better quality. Now I would like to make a bigger version of this, still using water cooling, kind of quite eccentric perhaps, with maybe 10 LEDs, but I might need Yuji's help for that, because they're relatively expensive LEDs. So Yuji, if you're watching, I would really like to pursue this, so send me an email or something if you're interested. Right, so I think that's it for this video. I've got some really exciting ones coming up in the next few months, so stay tuned for those. And other than that, I will see you in the next video. Goodbye for now. If you'd like to see another of my projects, then why not check out this one in which I show you how to make some really beautiful mushroom lights. Alternatively, if music is more your thing, then what about making a unique concrete volume knob to bring back that analog feel to your audio? They're both worth a watch, so I hope you enjoy them.